The advancement of battery technology is the new bullseye for companies striving to meet the world's growing appetite for EVs. A focus on battery life is currently still one of the top concerns for electric car buyers because the long-term operation of EVs depends mainly on the battery. However, scientists have figured out how to make a battery last up to 200 years, and this could completely change the electric vehicle battery industry. So stay tuned to find out more. 2 years ago, a sensation of doubt arose around the notion of a million-mile battery, an extraordinarily durable lithium-ion battery that could last decades while powering an electric vehicle over long distances and costing more or less the same as an ordinary battery. A million-mile battery is equivalent to around 70 years of battery life. Jeff Dunn, a Dalhousie University professor and lead battery scientist for Tesla, was also interested in this concept and gained more traction at the time when Tesla later said they were on the verge of actually producing such a battery. But just as soon as it gained traction, it was gradually forgotten. It turns out, however, that those leading battery researchers have quietly continued to develop batteries that last 1 million miles or longer. Accordingly, Tesla battery researchers with Professor Jeff Dunn have presented updated test results for their battery cells. Instead of 1 million miles, the batteries are now expected to last 10,000 cycles and provide traction power for more than 2 million miles, which is about 3.5 million kilometers, or around 200 years of battery life. Jeff Dunn explained the results from his work on particularly durable battery cells accordingly. To get there, Dunn described pairing a very good artificial graphite anode with a nickel-manganese cobalt battery called NMC 532. Dunn also shared with special additives, particularly the liquid separating the two electrodes, which would use chemicals such as methyl acetate to allow the battery to charge fast while not damaging it. The batteries should be able to withstand 10,000 cycles, assuming a relatively conservative 350 km range per cycle, for example, a full charge from 0 to 100%. This would be 3.5 million kilometers, hence this number clearly surpassed the 1 million mile that were announced before. 3.5 million kilometers, or 2 million, whichever one you like, it's still a big deal because now the lifestyle cycle for electric vehicle batteries is currently limited to hundreds of thousands of miles. Tesla is still offering a minimum 70% battery retention guarantee over a period of 8 years or 120,000 miles. The Chevy Bolts from GM has a standard 8 years, 100,000-mile warranty for its battery as well. According to Professor Jeff Dunn, if the cells were treated more carefully, specifically if the complete charge stroke from 0 to 100% was not used, the cells could even last 15,000 cycles. In fact, graphs published by a source show a much more constant cell capacity over 10,000 cycles with a charge stroke from 0 to 80% than with a charge stroke of 0 to 90 or 0 to 100%. If the batteries were only discharged by 25 to 50% of their capacity, they would show almost no degradation. This is a charge level range that many electric car drivers use in practice. The battery is rarely discharged to less than 20%. On the other hand, it's rarely charged over 80%. Dunn's Dalhousie lab reports that it has now cycled its experimental battery cell 13,000 times, which would allow a vehicle to travel 3.2 million to 3.7 million miles. Depending on how many miles were driven per year, while retaining an astonishing 93% of its initial capacity. But that's only if the battery stays at room temperatures of around 20 degrees Celsius or 68 degrees Fahrenheit. At more punishing but realistic temperatures of 40 degrees Celsius or 104 degrees Fahrenheit, Dunn cells have performed less well but still stoutly, lasting 6,500 cycles and retaining more than 80% of their initial capacity. In view of such range and degradation figures, Dunn himself raises the question of whether batteries are needed that are this good. He quickly answers his question with yes. For one thing, such durable batteries would not have to be recycled after use, he claims. Since they are as good as new, they could simply be installed in a new car after use in the first car, after it has been scrapped. On the other hand, they could be used in vehicles with higher requirements, such as commercial vehicles and electric ferries. In addition, 3.5 million mile batteries or 200-year life batteries that do not suffer from frequent charge-discharge cycles could also be better integrated into the power grid and stabilize the grid. Not only as stationary storage devices, but also in the vehicle. In order to nevertheless be able to store power in vehicles, the development of vehicle-to-grid, or V2G applications, is inevitable. In Jeff Dunn's vision of the future, electric cars double as renewable energy storage devices. He said, "You have to be able to store renewable energy for when the wind isn't blowing and the sun isn't shining." Equipped with long lifetime million-mile batteries, electric cars of the future will be brimming with unused energy. When the car is parked and night has fallen, excess energy can be redirected back into the grid to power homes, buildings, and anything else connected to the grid. Cars will no longer just consume energy, but could also be a valuable source of energy. This process of vehicle-to-grid energy is something Jeff Dunn is really excited about. In order for this to work, the batteries need to be extremely powerful. That's why he's hoping to finalize a battery that can last several thousand charging cycles. Several experts said that vehicle-to-grid sounds great, but it'll require buy-in from energy companies, car manufacturers, and governments. It will also require smart technology and vehicle grid integration. In other words, charging stations will need to be bi-directional in order to push and pull electricity between the cars and the electric grid. On the other hand, Tesla was rather reserved on the subject of bi-directional charging with reference to battery life. However, some sources revealed that Tesla was preparing a bi-directional charging function later on. Furthermore, most likely in the near future, Tesla's team of battery scientists and experts will quickly develop and apply million-mile batteries for its models. It will be one of Tesla's most terrific battery technology breakthroughs. Ultimately, has any electric vehicle company applied this million-mile battery technology? In China, BYD and CATL, the battery giants, are each advertising an electric vehicle battery life of 750,000 to 1 million mile, which is equivalent to 5 to 7 decades of average driving. Meanwhile, in the West, an AGM spokesman said that the company's Ultium battery, which will be used in its electric cars, will last 1 million miles or 1.6 million kilometers. They also promised its Ultium battery would be cheaper and more efficient than any other conventional battery. According to a report, there will be more than 300 million electric vehicles on the road worldwide by 2030. It's only 7 years away, so if we're to add 280 million vehicles in 7 years, we'll need a lot of batteries made using cheaper and more abundant materials. This is why scientists at Drexel were looking into a brand new type of battery that's cheap, with the price of $17 per kilowatt-hour, known as lithium-sulfur. So, why does this lithium-sulfur discovery make it the future of battery storage? Over the last few years, lithium-sulfur batteries have been touted as a strong candidate for marking a new energy storage era, but they haven't made it to the market yet. Now, a group of chemical engineers from Drexel University has found a way to enable their real-world application. Introducing sulfur into a lithium battery has been difficult due to what the researchers describe as an irreversible chemical reaction between intermediate sulfur products. This has resulted in nearly immediate shutdown and complete failure of the battery after just one cycle. Thus, the research team at Drexel was looking at ways to redesign the battery's cathode in order to prevent the damaging chemical reactions that take place during the charging process. But what they discovered instead was a rare chemical phase of sulfur that prevents the reaction. The result shows that this battery actually performed amazingly well. How much will a lithium-sulfur battery cost? In a world where commodity prices for battery materials are going crazy, switching to lithium-sulfur isn't just a good idea, it's an incredibly sensible one. Being the 10th most abundant element on Earth, sulfur is much easier to find than cobalt and nickel. Plus, it's obtained as a byproduct of various industrial processes, such as petroleum refining. Sulfur's price has also risen over the last 12 months by 47%. However, the cost of sulfur is dirt cheap currently at $382 per metric ton. To make the comparison, you can purchase nearly 200 tons of sulfur for what you pay to get 1 ton of cobalt. The researchers say they have optimized production costs, so that the lithium-sulfur battery costs 6 times less than Tesla's current 4680 battery. Again, that's about $17 per kilowatt-hour. That's why introducing sulfur into the cathode formulation would relieve pressure on the EV supply chain and could reduce the costs of EVs. How does a lithium-sulfur battery's energy density outperform that of a lithium-ion battery? According to the research, the energy density of a 4680 cell is 244 watt-hours per kilogram, while the energy density of the sulfur battery is expected to be around 723 watt-hours per kilogram. According to research, the energy density of a 4680 cells battery is 244 watt-hours per kilogram, whereas the energy density of the lithium-sulfur battery is expected to be around 723 watt-hours per kilogram. What does this mean in practice? Well, for instance, if you were to replace your EV lithium-ion battery with a lithium-sulfur one, you could drive your car roughly 3 times longer without needing to stop at a charging station. Alternatively, you could keep your existing range with a much smaller, lighter, and cheaper battery pack. Currently, top-performing EVs that use lithium-ion batteries have ranges that top out around 500 miles, but with a lithium-sulfur battery, a car with a battery that weighs exactly the same could travel up to 1,500 miles on a single charge. How long does it take to charge the lithium-sulfur battery? These new batteries have the advantage that they can retain 91% of their capacity after 1,700 cycles of fast charging at a rate of 2C, which means they can be fully charged and discharged in 30 minutes. The researchers add that these batteries can still hold 74% of their initial capacity even after 1,000 cycles at 5C, which go from fully charged to fully empty in 12.5 minutes. What does the C mean exactly? The C rate is the unit battery experts use to measure the speed at which a battery is fully charged or discharged. For example, charging at a C rate of 1C means that the battery is charged from 0 to 100% in 1 hour. For comparison, 4,680 batteries are made to keep at least 80% of their initial capacity for a significant number of charge cycles, and they fully charge in 52 minutes. So, what breakthroughs have scientists made on the lifespan of lithium-sulfur batteries? Despite the mystery, after a year of testing, Dr. Cholra and her co-workers proved their sulfur cathode stabilization over 4,000 charge-discharge cycles, meaning it lasts at least twice as long as lithium-ion, which is about 50 years. Where will this battery be applied? Lithium-sulfur batteries are also lighter, making them highly attractive for drones and electric planes. In fact, in 2020, LG Energy Solutions installed a lithium-sulfur battery in a high-altitude, long-endurance, solar-powered unmanned aerial vehicle developed by the Korea Aerospace Research Institute. It successfully performed well in a test flight at the highest altitude possible in the stratosphere for 13 hours. Besides that, a significant agreement by Australian company Elise Energy Inc. in 2022 was with leading US aviation company Magnix, which will test the potential of the lithium-sulfur cell technology for e-aviation applications. In short, lithium-sulfur batteries could allow a huge range of activities to go electric, such as short-haul flights, cargo vessels, and passenger ferries. The weight-saving, long life, and competitive price will mean these sectors can finally achieve their low-carbon goals. Still, this sounds like a lot of work. How long is it going to take for this battery to hit the market? We've been talking to a lot of industry folks to get an understanding of the steps beyond where we are right now, and our understanding of such technology would be more in the range of 5 to 6 years. Drexel's Viva Cholra highlighted some possible use cases, but we believe this is much sooner than 5 years. But that isn't the end of this discovery. The team at Drexel is currently looking into using this breakthrough to make sodium-sulfur batteries. By eliminating the need for lithium, batteries can become even more eco-friendly and eliminate a major supply chain bottleneck, ensuring that electric vehicle adoption can continue at the breakneck speeds that car manufacturers are currently planning for. Will Musk invest in this lucrative project? While Ford and Mercedes-Benz have partnerships with battery manufacturers to explore solid-state technology, Elon Musk is planning to incorporate lithium-sulfur batteries to increase the range of Tesla vehicles. This partnership with the Drexel team starts in 2023, and is supposed to revolutionize the EV industry's history. Drexel's unexpected yet radical achievement may finally bring the sought-after lithium-sulfur battery within commercial reach. With lower cost, higher power density, and greater durability, this technology would change the way we think about energy storage for good. Having said that, scientists will still need to prove their optimized device outside of the lab, so our cars, smartphones, and drones will have to wait a little longer before being supercharged to the next level. How do you feel about the future of lithium-sulfur batteries? While the automotive industry puts a lot of faith in their current battery lineup, what would happen if a battery appeared that could have a life of up to 3 times longer, and charge up to 70 times faster than your typical lithium-ion battery? These are exactly the battery innovations that Graphene Manufacturing Group has to offer. So, how does this groundbreaking battery charge so quickly, and what other advantages does it have? This world-exclusive type of battery is a significant step closer to reality thanks to Graphene Manufacturing Group, GMG, and the University of Queensland research, as well as UniQuest commencing their scale-up research project on the graphene aluminum-ion battery. Not only is it cheaper, faster to charge, and lightweight, but it also features better environmental credentials and has a longer lifespan than other lithium-ion counterparts. So, how much is the price of graphene aluminum-ion batteries? The materials used by GMG's battery, including natural gas and aluminum, are readily available throughout the world. All those hard to source, hard to process, and hard to dispose of rare earth elements would be unnecessary. The average price of a Tesla 4680 battery pack was $101 per kilowatt-hour in 2022. Mr. Nicol, CEO of GMG, calculates that this new battery costs roughly $25.25 per kilowatt-hour, or nearly 4 times less than the 4680 battery from Tesla. Thus, if you own a Tesla Model Y standard range with an estimated battery capacity of 60 kilowatt-hours, replacing the battery pack with a graphene aluminum-ion will cost you $1,515 instead of $6,060 for a 4680. For a revolutionary battery, this cost is really inexpensive. Mr. Nicol also stated that he is convinced the batteries manufactured by his business would also be more cost-effective than those already on the market because of a less intensive material basis and lower overall weight, which clearly pays off in logistics. But charge time is what most electric vehicle owners care about. So, how long does it take to charge a graphene aluminum-ion battery? The graphene aluminum-ion cells from the Graphene Manufacturing Group are claimed to charge up to 70 times faster than the best lithium-ion cells. This battery charges so fast it's basically a supercapacitor. The GMG CEO claims it charges an iPhone coin cell in less than 10 seconds. These characteristics compare favorably against typical rechargeable lithium-ion type coin cells, which take 3 to 6 hours to recharge. But what's the breakthrough in the weight of GMG's battery? Tesla's 4680 battery cell weighed in at 355 grams, compared to 89 grams for the graphene aluminum-ion cell. Nicol is talking about the major nanotechnology breakthrough GMG's graphene cell presents, developed by the University of Queensland. The surface perforation of graphene allows aluminum atoms to sit tighter on them. Nicol says that this is what allows GMG's cells to be so much lighter. Furthermore, graphene aluminum-ion batteries provide major benefits in terms of longer battery life. So, how many years can we actually expect it to last? Cycled over 2,000 charge, discharge cycles and testing so far with no deterioration in performance, which means it could last up to 45 years. In contrast, lithium-ion batteries have a lifespan of up to 15 years at best as their performance degrades with charging cycles. Now, how would the energy density of this battery compare with lithium-ion? When it comes to energy density, the graphene aluminum-ion prototype cells tested so far are not that impressive. They have presented an energy density between 150 watt-hours per kilogram and 160, while Tesla's 4680 batteries would offer 260. But that is not something of concern for Nicol. He claims that it has the potential to present 3 times the energy density of lithium-ion cells. In fact, the Oak Ridge National Laboratory has once presented an aluminum-ion cell with 1060 watt-hours per kilogram. Lithium-ion's limit would be 406. But besides that, another significant advantage this cell presents is that they have a higher power density of 7,000 watts per kilogram. For comparison, lithium-ion batteries deliver a maximum of 340. Another major point that we have to discuss is safety. So, is this battery actually safer than lithium-ion? Graphene aluminum-ion batteries do not overheat nearly as much as lithium-ion batteries do. They are nicely below zero so far in testing. Almost 20% of the weight and cost associated with a lithium-ion battery pack is attributable to high-performance cooling systems, which can be eliminated in most graphene aluminum-ion battery use cases. They don't need circuits for cooling or heating, which currently accounts for about 80 kilograms in a 100 kilowatt-hour pack. How does graphene aluminum-ion battery affect the environment? Directly created from natural gas, graphene powder is produced by GMG's patented production technique, which has clear environmental advantages. Using nanotechnology developed in conjunction with the University of Queensland, powder is crushed into a pellet shape and implanted with small aluminum ions. About 90% of aluminum products are currently recycled, and GMG's graphene aluminum-ion battery would be incorporated into this well-established aluminum cycle. Besides that, hydrogen is a byproduct of the fabrication of graphene aluminum-ion batteries, which has additional use in the transportation sector to power fuel cell electric cars. Can it be applied in real life? GMG CEO Craig Nichols said, We are currently looking to bring coin cell commercial prototypes for customer testing in 6 months and a pouch pack commercial prototype used in mobile phones, laptops, etc., for customer testing in 18 months. He thinks there are a lot of opportunities for this technology in automotive applications, especially given how well it performs in fast charging and regenerative braking conditions. According to GMG, the aluminum-ion battery is virtually interchangeable with the lithium-ion battery in many applications. When do you think we'll start seeing graphene aluminum-ion batteries out on the market? So, how is this new battery structured? The researchers chose aluminum, the most abundant metal on Earth, as one electrode. As a bookend electrode, they picked sulfur, the cheapest non-metal. Then came the time to search for the right electrolyte. They avoided the flammable organic liquid electrolytes used in lithium-ion batteries and chose a chloroaluminate molten salt, which needs to be a liquid to be activated. This battery operates at the salt's melting point of 110 degrees Celsius, but Sadoway says they have already brought that melting point down to 65 degrees and can see ways to get to room temperature operation. But how will this new battery be priced compared to lithium-ion? The three ingredients are extremely cheap and earth-abundant, compared to lithium, nickel, cobalt, and graphite used in lithium-ion batteries. Aluminum is no different from the foil at the supermarket. Sulfur is often a waste product from processes such as petroleum refining and widely available salts. Given the availability of all the components, the researchers estimate the cost of the aluminum-sulfur battery to be as low as $8.99 per kilowatt-hour. That's 12 to 16% of the cost of today's lithium-ion batteries. Finally, the team notes that the simplicity of the chemistry should boost the recyclability of the batteries at end of life. In the midst of all this shocking innovation, will aluminum-sulfur batteries perform well enough for us to turn away from lithium-ion forever? The battery already shows an energy density of almost 530 watt-hours per liter on par with common lithium-ion chemistry, and it's still in the early stages, Sadoway says. So, improvements are very likely. I would remind you that when you compare aluminum-sulfur today with lithium-ion, a fair comparison would be to compare lithium-ion in 1993, he says. So, how long does it take to actually charge the battery? It can't be less than a minute, can it? In their experiments, the team showed that the battery cells could endure hundreds of cycles at exceptionally high charging rates. In some cases, the batteries charged to 100% power in less than a minute. They heat up in the process, but the engineers found that they actually work better at higher temperatures. 110 degrees Celsius exhibits 25 times faster rates than 25 degrees Celsius, which is a big breakthrough. So, what else makes aluminum-sulfur batteries the holy grail of batteries, and is it actually safe? Surprisingly, the molten salt the team chose as an electrolyte, simply because of its low melting point, turned out to have a fortuitous advantage. One of the biggest problems in battery reliability is the formation of dendrites, which are narrow spikes of metal that build up on one electrode and eventually grow across to contact the other electrode, causing a short circuit and hampering efficiency, which is a polite way of saying a battery fire. But this particular salt, when it happens, is very good at preventing that malfunction. Chloroaluminate salts are crucial for the battery's success. What's more, the battery requires no external heat source to maintain its operating temperature. The heat is naturally produced electrochemically by the charging and discharging of the battery. In a typical installation used for load leveling at a solar generation facility, for example, you would store electricity when the sun is shining, and then you would draw electricity after dark. And you do this every day, and that charge idle discharge idle is enough to generate enough heat to keep the thing at temperature. So, how can aluminum-sulfur batteries be applied to everyday use? For the opening act, small-scale storage systems with capacities of tens of kilowatt-hours seem like a perfect fit for the aluminum-sulfur battery. Today's lithium-ion batteries are still too expensive for such energy storage applications. This battery would be ideal for a single-family home. You'd be able to have a 50 to 100 kilowatt-hour pack to get you through the night and a couple of days of cloudy skies. The smaller scale of the aluminum-sulfur batteries would also make them practical for uses such as electric vehicle charging stations, Sadoway says. He points out that when electric vehicles become common enough on the roads, several cars want to charge up at once, as happens today with gasoline fuel pumps. So, having a battery system such as this to store power and then release it quickly when needed, could eliminate the need for installing expensive new power lines to serve these chargers. Moreover, because the molten salt electrolyte is thermally stable above 500 degrees Celsius and immune to thermal runaway and fire, the researchers argue that the battery chemistry is likely to be especially attractive for electric vehicles and electronic devices. Satterway has already made the research the basis for Avanti, the spin-off company he co-founded that has licensed the patents for the battery technology. So, then we're going to see real-world applications of aluminum-sulfur batteries, right? It's looking more likely by the day. Aluminum-sulfur is still in the lab but shows exciting possibilities. No matter what, it's not about one technology killing another, it's about finding the right tool for the right job. The mining industry has overhyped new strategies and technologies before, including lithium-ion batteries when they were first introduced. However, aluminum-sulfur batteries could be the start of something significant. These materials may take over the industry and become critical players in powering eco-friendly devices, helping to create a greener, better world. So, what's the future of aluminum-sulfur battery technology? We're just going to have to wait and find out. If you enjoyed this video, please give it a thumbs up. Thanks again for tuning in and we'll see you in the next one.